Okay, the next section that we need to take a look at is this idea of secant lines in relation to segments. The last one was looking at angles, and this one now is taking a look at those segments. And so we're going to start by looking at a couple of different situations that could happen. What could happen is segments could intersect inside a circle. They also could intersect outside of a circle. And so we're going to look at these two different situations, and then we'll go ahead and look at some examples with them. Okay, so make sure that you're filling in these notes, getting down the equation so that you're ready for the examples later. Okay, the first one, if they are intersecting inside of a circle, we have to remember that the product of the length is how long it is, what its measurement is, of two segments from the point to the circle is consistent. What this means is that they will equal the same of another length. The product of the two parts of one length will equal to the product of two parts of another length. And so what that really means is when we look at this situation here, the length A times the length B, right? This part of our line times this part of the line is equal to C times D, where now we're looking at this part of the line times this part of the line. So anytime that you have two segments that are intersecting inside of a circle, the product of the length of the two segments is equal to the product of the lengths of that other part. Okay, make sure that you have this equation here written down. We're going to come back and look at these in the examples. And now the next situation that could happen is these segments could intersect outside of a circle. You'll see two situations here where they could intersect outside of a circle. You see some lengths of it, right? And now we need to keep in mind that the product of, I'm going to write the entire length product of the entire length of that segment and the outside length, so just the piece of it outside of the circle, of two segments from the intersection point to the circle is consistent. And so what that means is it's saying if I take this entire length and I multiply it by the part of that outside, then that is going to be equal to if I took this entire length and I multiplied it by just the piece on the outside. Now notice these two segments, they have to be meeting at a point. So they have to come out to this point here in order for this to work. This equation looks like n plus m times n, right? Our entire length plus just our outside part is equal to Q plus P times Q. Again, that entire length times just the outside piece. Now, the second situation, you'll notice it looks a little bit different. right? The entire length is the outside part. And so in this situation, what we're going to have is x squared. It's basically saying the same thing. What's the entire length? Well, this entire segment is x. Okay, times the part that's outside, x. Well, x times x is x squared, right? So it's the same idea, but it looks a little bit different. Times y plus z, that entire length, times z, the piece that's outside. Okay, so these are our equations that we're going to be using and working with here. So let's go ahead and take a look at some examples. Our first example says we're looking for something inside. Now remember, our equation here is a times b is equal to c times d. So it doesn't matter which part is a, b, c, or d, but make sure that a and b are on that same line, that same chord, and that c and d are the same chord. So I'm going to say 6 times 5 is equal to 4 times x. Well, 6 times 5 is 30. 30 is equal to 4x. Okay, I divide that on both sides, and we would find that x is equal to 7.5. Now, when you get to the end, you might want to just double check it, plug it in there, right? 7.5 times 4. Make sure that's equal to 5 times 6. But in this situation, it works, right? This was inside the circle, and so we use this equation here. Okay, so here we have another example of lines intersecting inside of the circle. Again, our equation here is going to be a times b is equal to c times d. And so remember that it doesn't matter which is a and b, just make sure they're on the same line. So these two numbers here have to kind of be on the same side of the equation, and these two sections here have to be on the other side, okay? That a and b and the c and d. So let's have 15 times 7 is equal to 10 times y. Okay, so we're going to multiply this out. 15 times 7 is 105, and that's going to equal to 10y. Well, as we're dividing that, we're going to find out that y is equal to 10.5. Okay, here's an example where these lines are intersecting outside of the circle. Okay, now remember, we want to take the entire length times the length on the outside and do that to both sides. They should be equal. So we're going to have 8, right? 6 plus 2 is 8, times 6 has to be equal to that entire length over here, which would be 4 plus x, times that outside length, which in this case is 4. So we have 48 is equal to 16 plus 4x. We need to keep doing some algebra to solve this. We're going to have 32 is equal to 4x. And so x is going to be equal to 8, which means this length right here will be 8. Okay, here's our next example. Now remember, we want to take this entire length times the outside length. And that should be equal to the other entire length times the outside length. So let's go ahead and set that up. In this case, 6 plus 8 would be 14. We're going to multiply that by the outside amount, which here is 6. And then we have the entire length, which is 4 plus x. And we're going to multiply that by the outside amount, which is 4. Okay, 6 times 14 is 84. And so we're going to have 4x plus 16. Now I need to get that x all by itself. So as I start rearranging, I'm going to subtract 16 from both sides. 68 is equal to 4x. Which means if I divide it, I'll get x is equal to 17. So this length here is going to be 17. Nope, that length is going to be 17. Now let's go ahead and check it. All right, 6 plus 8 times 6. Okay, which means 14 times 6. What's 14 times 6? That's going to be 84. Okay, now that should be equal to the other side. So on the other side we have 17 plus 4. We're going to multiply that by the outside amount. So 17 plus 4 is 21 times that 4, and we're going to get 84. So it matches, right? Both of those amounts should be equal to each other. Okay, now we have another one. Again, looking at the entire length, which is 12 plus 4, multiplied by the outside amount, which here is 4, has to be equal to this length squared. So we'll have 16 times 4 is equal to x squared. 16 times 4 is 64 is equal to x squared, which means x is going to be equal to 8. This length right here is going to be equal to 8. Okay, this last slide is really just recapping for you those properties that we've taken a look at in this section, both dealing with angles and segments. And make sure that in your notes you have these diagrams and also those equations, right? The equations that we use to either find a segment length or an angle length based on if it happens inside of a circle or outside of the circle. So if you don't have these in your notes, make sure you write them down, okay?